Hi, this is Matt Genovese. I'm the founder and CEO of Panorama Labs. I'm going to give a quick introduction and demo of Sinfonia for hardware design and verification. Just a quick background, I have about a 29-year career in high tech, starting in chip design and verification on PowerPC, and then moving over to enterprise SaaS product development and spending a large part of my career designing products and getting them out into the wild. We built Sinfonia as a way to close the gap between design intent and verification intent, and really to handle the day-to-day engineering workflows and using AI in a very prescriptive way in order to accomplish that. I'm going to jump into a demonstration. I'm not going to make this into a big slide deck presentation. It could be a two-part. First of all, we're going to talk about Visual Studio Code, and we're going to show how an extension that we're building upon connects into Sinfonia and allows for an acceleration of perhaps some of the mundane and more time-consuming parts of RTL design. And really, again, let's designers focus on what they do best. And then we'll go over to the Sinfonia platform. That's where it's more of a hub for all the kinds of specs that we might have, design assumptions, and including verification plans can also live there as well. And that's what, again, is the hub for all the information that goes into a design project. Before we go over to that, I'll just talk a little bit about Sinfonia and what we're doing. It's really meant, for what we're going to show coming up here, we're really trying to, for the designers, accelerate, again, the more mundane parts. So doing some things like automated standardized RTL documentation and line commenting. I'll show actually, I'll just jump over and show you an example. For example, having a set of documentation that exists in your Verilog code, in your RTL, that is standardized across all of your Verilog files. And that can be both at the module level, at the various blocks within a module, and constructs there, handling combinational sequential logic state machines, and standardizing that across all of the modules within your project. We'll also be looking at explanations of RTL logic, and really at any size. Human style AI linting, right? So look, basically a second set of eyes. And I want to make clear that one of the challenges that language models have to date is performing well with agents. And agents can do a lot of things, but there are challenges with them. And so we're not trying to overextend what language models are able to do today. We track it very closely, of course. We want to make sure that we're on the forefront of it, but we're also cognizant that we don't want to overextend what they can do and actually create more work for designers and more work for verification engineers and the like. So we're really trying to keep within the bounds of what is possible and still accelerate the work of each of these engineers working on design projects. Okay, so what we're looking at here is a RISC-V processor implementation, and in fact, it's the Pico RISC-V 32-bit processor. It's available on GitHub, actually, and what I've done is I pulled out, just for ease of use, I pulled out the integer multiplier. It's a 32 by 32 multiplier module, and the whole module is right here. It's short enough where we can actually walk through it and do some examples. So the first thing we want to do is maybe do some auto documentation. Let's go and take the module itself, and we're going to ask it to explain. Now, in this case, what explain means is that we're going to have it write the module header for it. And in doing so, it will suggest that header based on the template that we've provided in Sinfonia. And right now it's showing a diff. So here is the proposed changes. And if I go and hit save, now those changes are implemented right here. And again, as I showed in the presentation slides earlier, we can use any template that we want for the documentation for the module header, also for blocks within the module, so always constructs and things like that. and have it create a standardized way of having these headers created across all of your modules across the entire design RTL. And it's very quick, so that it happened very quickly. Let me come over here now, and here's an always block. So what we'll do is we'll kind of do the same thing here. We're going to select the always block. This time we're going to go say add to context. And I can say now write inline comment. Write inline comments. And so what it's doing now is, again, it's using information about this block against the context of the entire block and against the context that is stored within Sinfonia of the RISC-V implementation. All the spec docs and things like that from the RISC-V website are integrated into Sinfonia in that project. So now it's coming back and saying, okay, I've analyzed what that is, and I'm going to suggest the comments here. Let's go back and save it so you can read. Now we have, it's a synchronous process, and it's doing the decode. And then it also added comments within here as well about what's actually happening, what's being done in terms of the type of multiply instruction being selected. And again, we have other parts too. So this was here synchronous logic. I can come down here and we have, of course, this is combinational logic. So I'll come over here and do the very same thing. I will add this to the context, and I will say write inline comments. And now it's going to recognize that this is likely combinational. I'm saying that because I know it is, but I'm letting it determine it for itself. And because we programmed into Sinfonia the type of headers that we're going to use. Again, let me save this. Now we have this header added. Now this was what was there before. We can actually remove that. And here's a combinational process. It's tell you exactly what's happening and even walks through step by step. And what's great about this is that you have now not only a way to automate creating these comments in your code, but you also have a way to validate and have a second set of eyes about what you're actually doing. We would, of course, suggest that any designer would be looking at this code, looking at the comments, and validating that this is actually what's happening. And if there is confusion, maybe it's because the AI got it wrong, which might well be, but it also could be that perhaps there's a bug and it's interpreting what was done and it was not actually what the plan was for the designer. And so it gives a place for them to go back and review what they've done and decide if the AI got it wrong or if they got it wrong. So it's a way to find defects perhaps before you actually have your code submitted to the repository. We can do other things too. Let's go down. We're going to pick these wires here. Let's see. I think we're going to do these here. And we're going to say add. Let me see. Is this the one I want? No, these here. These are the ones I wanted. Here. And I'm going to say again, add to context. And now we're going to say, hold on here. One more thing. We're going to say, explain what this is. Now what it's doing, we're not inserting any code into here, but what it's doing is it's telling us, here is what every one of these wires are doing, or these regs and wires are doing. And in fact, it allows anybody who is coming into the code base, especially if they haven't written the code, written the RTL themselves, to be able to understand what's happening. This is especially useful for junior engineers or people who are just becoming accustomed. You could do this for the whole module, actually, but I'm doing it just for a set of wires here. And it's a very useful way of just getting accustomed to what is happening in the module at a high level. Again, if you've had comments throughout here, you may not need this, but you can take any set of RTL and bring it over and get an explanation of what is happening. Again, because we have information also stored within Sinfonia about the design specifications for the processor, or the SoC or whatever design it is, it can use that information as well as what's here in order to provide better output and explanations for what's actually happening. Let me see. I think there is one more thing we'd like to do. I'm going to jump over here, and I'm going to say, for this file, so I'm going to reference the file, this particular file. I'm going to say identify any signals that are assigned but never used. Now this is a way where you can also interact with Sinfonia and ask questions about what is happening in the application, almost as if, or in the code base, even as if you were doing a check, right? More like an AI linting, or somebody looking over your shoulder and saying, well, let's do a check really quick and see if there are any that are not used, right? Now in here we have that it's reviewing all the signals that are assigned but never used, right? And these in fact exist. However, what it also realizes is that these signals are used to create wires, and those wires are indeed used. So while it may look like that there are certain entities that are not actually being accessed by their name currently, they are being accessed through the wire that was made to aggregate them all. So that's very interesting to do as well. And there are many of these that could be automated into checks that are run in a batch, so that you could have a number of these checked off and say, okay, it seems like that we've gone through all of this effective linting and validating that the module is up to snuff in terms of the types of checks that we wanted to run. And you can also here, just we can do things that I'm not even going to try to bore with. Like for example, we could change one of the signals here and see if it will find the bug, and many times it will. And it's really interesting to be able to go and ask if it's just finding any issues with this, and it does tend to work many times to show that. So there are ways that you can build in some checks into Sinfonia and into the RTL experience for the designer that will help them do their job better, and perhaps even find defects before they ever make it out to verification. And what we're looking at now is Sinfonia. Sinfonia is a web application that you can access through the web. I'm showing it right here. And this would be used by anybody working on the project at hand. So in this case, we're talking about the Pico RISC-V project. We have a project created already called RISC-V Test. And it's really meant to be used by designers, by verification engineers, and anybody who is involved, including in the specifications of the project. So what you don't see right here is that we have embedded in all the documentation about RISC-V into the Sinfonia project. And that exists in the background, and that is what the coding agent that we were showing earlier in VS Code, in Visual Studio Code, is connected to. So now by having access to all of that documentation, the VS Code plugin that we showed earlier is able to access and use that information while the designer is doing their work. And yet this is the hub for all of that documentation, and we can also use the same interface for creating verification plans that are used by the team as they're building out their tests. So one of the things that we did here, and I'll show this just very easily, we have a way of breaking this down. So you could start with the integer multiplication tests for signed numbers. You could do this for unsigned numbers. We can create more of these areas within. And then we started breaking it down and said, well, what type of tests do we want to create, right? We can multiply by 0, multiply by 1. We can multiply 2 positive numbers, 1 positive, 1 negative, and then we can start writing out what the tests need to be. And in doing this, we now have an interface that anybody can go and use from the team and review the verification plans, even make comments on it. So we could have conversations here, descriptions about what actually is happening, have comments here as well between the designers and the verification engineers, or between the verification engineers on the same team, making comments about each item. But this is a way that we can collaborate among different team members, especially if they are in different locations, which is often the case in chip design these days. We may have people across the globe collaborating, and in the same project we can use this interface to communicate with each other about test cases that we're looking at running. And so this is one way to start creating this. We actually also can start using. We actually have some ways to suggest items beneath by using the information, the specifications that are in Sinfonia for this project to start suggesting what verification test cases we might want to run. But here are the ones that we've created so far. And you may be able to spot it, but there is actually one that is missing from here. And so what we'll do is we're going to come back to our assistant and say, we're going to jump over to our assistant here, and we're going to say, okay, let's ask the question. And I'm going to just copy and paste it over here. Are there any gaps in my verification tests for integer multiplication? And so this is giving us an access to an assistant, which is, again, is connected to this project that will look at what we have already implemented here in our test plan and going to look for, basically do a gap analysis. And so what does it come up with? It says, okay, you have one positive, one negative, you have two positive, you have one, multiplication by 1, multiplication by 0. These scenarios are here. Okay, but look what it, so I missed a couple other ones here, but let's jump down to here. It said multiplication of 2 negative numbers. That was one that I missed. And actually when I was putting this demo together, I just went very quickly and created this test plan. And I didn't even catch that I had missed that particular one. So it really did catch me and let me go back and correct that. But of course, it's looking at the specifications for RISC-V and saying, well, look, there's other capabilities here that you may want to test and build that into your test plan. It becomes very, very useful to use this as a way to interact and, again, do a type of linting, a type of review of your verification plan in order to make sure that you are hitting all the tests that you would want to hit. And I also want to talk about the idea here that by having the verification plan and the specs and the designer's code accessible by the language model, by Sinfonia, you have the ability to start looking at what test cases are being written here and where the RTL is being written that will effectively affect that test case. And to be able to draw linkages between them, I think is very useful. And that's one area that we're exploring, and how to really bring together the designers and the verification engineers and ensure that any tests that are being created are connected perhaps to the RTL. And likewise, any changes and additions or RTL that is written by the test engineer or by the design engineer could be turned into tests that are required in order to validate that functionality going forward. So there's a lot of flexibility here, a lot of possibilities with Sinfonia as a means to be a hub for all the information about the specifications and to connect to where the verification engineers and designers are doing their work. So now I'm jumping back to the slide deck here, and I want to just kind of wrap this up and talk about how we're addressing the problem here. And I do want to be clear that I was a verification engineer myself for a number of years, worked with a lot of folks on the engineering side of hardware. We are certainly not at the point where we can replace designers and engineers. And I know there's, again, a lot of thinking and ideas about how to automate and even create code, auto-generate code and things like that. And what I've heard repeatedly from people that have been working with those type of solutions using generative AI is that it's just not ready for prime time yet, and that many times the code that's generated is more junior level or lower, and it requires more effort to actually go back and fix it. So the whole idea here is not to over-automate, but instead really try to address where the challenges are, where the slowdowns are for engineers, both on the design and verification side, and help them to just be more efficient. We certainly don't want to disrupt the other EDA flows. Realize that there's a whole set of tool flows related to EDA, from going all the way from specifications to GDS2, and we're not trying to get in the middle of that necessarily and touch any of those. This is more of a drop-in that allows designers and verification engineers to just accelerate and collaborate better. And so we are trying to support them and doing so, consistently across their day-to-day workflows. So that was really it. If you'd like to learn more about Sinfonia and our efforts here, please reach out. You can contact us at sinfonia.digital. And thank you very much for your time.